all. In this video, we're going to look at chemical equations and how to balance them. Chemical substances, elements, or compounds react in many different ways. During a chemical reaction, the atoms are rearranged to make new compounds. We represent these equations, or rather these reactions on paper, with a chemical equation. Here's an example. In the beaker, there's hydrochloric acid, and in the bottle, magnesium metal. These things will react. Take a look. Magnesium is reacting with hydrochloric acid to produce magnesium chloride and hydrogen gas. The gas, the hydrogen, the gas, is escaping. That's what you see bubbling and coming out of the beaker. So again, on paper, we use a chemical equation to represent the reaction between different chemicals. What you just witnessed was hydrochloric acid, HCl, reacting with magnesium to produce magnesium chloride and hydrogen gas. So we use the chemical symbols to represent the chemicals in the reaction. The things on the left, we call the reactants. They react. The things on the right, we call products. They're what are produced during the reaction. So reactants, products. Chemical reaction represented as a chemical equation. There's one other thing we need to do. We need to balance this equation. As it's written, it's not balanced. The reasoning here is that you cannot destroy matter and you can't create it. It only changes forms. We call that the law of conservation of mass. Any chemical equation must conform to that law, where the amount of matter on the left in the reactants must be the same as the amount of matter on the right in the products. So reactants and products must be the same. So we balance the equation in order to do that. Okay, so let's use a visual to help understand how to balance a chemical equation. Again, the idea here is that the number of atoms in the reactants need to be the same as the number of atoms in the products. Law of conservation of matter. So we'll start with the reactants. We have HCl, hydrochloric acid, and magnesium. So magnesium will represent with a black cube, there's an atom of magnesium, and hydrochloric acid will represent with an orange and green combination, where green is hydrogen and orange is chlorine. Those are the reactants. Now over in the products, MgCl2, which if you do crisscross method, magnesium chloride, that's its formula. So we need one magnesium and two chlorine atoms. So we'll put those together here. And again, each block represents one atom in our reaction. H2, we're going to connect two greens because the formula here is H2. Okay. And just a note, something to keep in mind. In a formula, these small numbers to the right and below the symbol of the element, that's a subscript, okay? And that's part of the formula of the compound, and it's part of the identity of that compound. I'll say more about that in a moment. Now, we need to balance this. So what we're going to do is we're going to change the number of each substance so that we obey the law of conservation of matter. I like to tell students to go one element at a time. It's often helpful to save hydrogen for last, but go one element at a time, okay? So if we take a look at magnesium, we have one magnesium atom in the reactants, and we have one magnesium atom and the products. So magnesium right now is balanced, okay? If you look at chlorine, we have 2 atoms of chlorine in the products, 1, 2. However, we only have 1 atom of chlorine in the reactants, so we need to change that. So here's a chlorine, again, orange, okay? But here's the thing, I can't just do that, okay? Because this substance isn't chlorine, it's hydrochloric acid, HCl. So if I add another chlorine, a hydrogen comes along with it. So now I have 2 hydrochloric acid particles, okay? That balances the chlorine, 2 on this side and 2 on this side. So now I need to balance hydrogen. Actually, no, I don't. I do, but if we look, we have 2 hydrogens on this side and 2 hydrogens on this side. Magnesium hasn't been changed, so magnesium is good. So by adding 1 particle of hydrochloric acid, we balance the equation, okay? On this side of the map, in the reactants, we have 2 particles of HCl and 1 magnesium atom. In the products, 1 particle of magnesium chloride and 1 molecule of H2. If we tally up the atoms, green, 1, 2, 1, 2, so 2 on each side. Okay. Orange, 2 on this side, 2 on this side. Orange is balanced. And black, 1 on this side, 1 on this side, 1 and 1. So on this tally table of sorts, when the number of atoms of each element are the same in the reactants and the products, your equation is balanced and it obeys the law of conservation of matter. You're not creating matter, you're not destroying it, you're only rearranging it into new forms, okay? So that's how you balance an equation. You start with your reactants and your products, and you add particles as necessary by changing what are called the coefficients, okay? When you balance an equation, you may change the coefficients, you may never change subscripts, okay? Because again, the subscript is part of the identity of the substance. So you change the coefficient by adding particles as necessary, whole particles of either the reactants or the products, to balance the equation. Okay, so what you'll do now is try some of these with a partner with the same kit. Have fun, do your best. Everybody, so to continue here, to complete the assignment for today, you're going to click the link in Classroom, which will take you to this web page. This is a simulator that you can use to practice balancing chemical equations. And again, the idea here is that the equation on paper represents an actual chemical reaction, okay? And it needs to be balanced because you can't destroy or create matter. Whatever matter you begin with in the reaction has to be the same as what you end up with at the end. So when you open up this web page, you're going to start with the introduction. Maybe. There we go. And you're going to work through these 3 examples: ammonia, water, and methane. Okay. With tools, click on tools and choose the balance. Okay. Now again, these are your reactants. In this example, we have nitrogen and oxygen. Okay, which on the balances show up as 2 atoms of nitrogen and 2 atoms of hydrogen. And these are both diatomic in their pure form. They have a subscript of 2. That's their formula. We'll also add 1 ammonia here in the product. Okay, one nitrogen atom and 3 hydrogens. Okay, so again, these things react. Arrow is the reaction, and these are the products. Okay, to balance the equation, you have to adjust these coefficients. Okay, so I'll start with nitrogen, and when you're doing this on paper, just go element by element. So nitrogen, I have 2 atoms of nitrogen here and 2 Over here, N, I have 1 atom of nitrogen. So I'll add an NH3 to try to balance the nitrogen, and that works. If you look at the balance tool here, nitrogen is balanced. Now I need to deal with the hydrogen, okay? So with hydrogen, I have 6 here, 6, and only 2 in the reactants. So I'll adjust the coefficient. I have 2. Now I have 4 atoms, 2 pair of H2. I'll add 1 more, and the equation's balanced. It's happy, okay? In this reaction, we start with 2 nitrogen atoms, and we end with 2 nitrogen atoms. We start with 6 hydrogen, and we end with 6 hydrogen, okay? So work through the ammonia, the water, and the methane example. Once you've done that, what you then need to do is at the bottom here, click Game. And what I'm going to ask you to do today is to work through all 3 levels of the game. Each level has 5 equations that you have to balance, okay? Really? Really? Are you going to say hi now? Or are you going to be shy? Say hi, Pete. Sorry, a little interruption there. My apologies. So you have to do all 3 levels of the game. Now listen carefully. These are the directions then. To be credited with having done this lesson, at the end of the game, you'll get a score like this. This is mine from earlier. I missed a few just to mix it up a little bit, okay? Here's what you need to do. Take a screenshot that includes this screen and your name in the upper right-hand corner of your laptop screen, okay? Again, on your MacBook, Shift-Command-4 will switch to a screenshot, and you need to do a screenshot including your name and your results from the game, okay? And this is purely completion, so as long as I see that you completed this and worked through it, you do get the credit for today. All right, so hopefully that's helpful. I also attached some notes to this lesson to help you with this, okay? All right, everybody, thanks, and do your best. All right.